FMT 100, Unit 8, Section 4, Feeler Gauge. And no, I had a really bad song break into my mind, so I'm not even going to go there. So, also known as the thickness gauge method. All right, so this is not the world's greatest, okay? So what we're going to do for a feeler gauge is nothing more than a thin strip of calibrated metal. The thin strip usually has printed on it its thickness, and the feeler gauges can come in a delightful array of thicknesses that some of the thicknesses are even thinner than a human hair. So yes, they can be really thin, kind of a pain in the butt to work with depending on what you're working on, but it is what it is. So what you do is you get everything as closely aligned as you possibly can, and you use a straight edge, and you go about your business and you have typically it's done off of um, both sets of couplings. You primarily, once again, work off the poor fixed position, which ones is going to be either your pump, your gearbox, blower, whatever. And so you use your straight edge, and you make sure your shaft of your fixed position is level, and then you use your straight edge, hopefully with a level, you make sure that's level, and then you take your feeler gauge, and if there's a gap between your straight edge and your movable coupling, use the feeler gauge to see how much of a gap. And then if there is no gap, so let's say if the uh, motor side, the coupling's higher, the motor coupling's higher than the pump, well then you'd flip it around and see how much difference there is between the two. Uh, you can use this method to kind of get everything close, and it may even be all right for a flexible coupling, but this method will not fly for a rigid coupling. So like it's said, it's great to get you in the ballpark, uh, but in all reality, you're gonna have to use a different method to make sure it's really close. So this is a taper gauge. It's kind of like um, a feeler gauge, and it is. What you do with this one is you would slide this taper gauge in that open space, and when it stops, you would read the measurement of where it stopped. So if we go from the left and we go to 0.05, if we had the edge of our straight edge or whatever stop just past 0.05, it would be the measurement would be 0.051. So let's see if I can get our cursor to show up here. So I'm looking for this line right here. We stopped on the line just past 0.051. Then that's where we call it. I don't like these. I've always found these to be a pain in the butt to use. They're not as flexible. You can't get into really nice areas with them. So I tend to avoid using these. So once again, we're identifying how far the flanges are out of tolerance. Um, it's all subjective. That's one of the reasons, because you don't want to shove it in and you're waiting for a tight fit, but your tight fit, my tight fit may be different, and depending on how we shove it in and what our clearances are, we may not be able to get the feeler gauge in all the way for an accurate reading. It's just there's way too many variables, and that's one of the reasons why the feeler gauge method is, like I said, it'll get you close, but is not the preferred uh, final answer there. Um, you saw a taper gauge, and then some will say, well, you could use a dial caliper. A dial caliper, while it looks like it has a dial indicator face, it's not the same thing. And All you're doing is once again, you're literally going in with a measuring device that you typically use to find the thickness of something, and you're trying to force that to do the work of a dial indicator. It's chunky, it's clunky, and it's not that great. So these are some of the other methods. Once again, it'll get you in the ballpark, but to really tighten things up, you're going to have to use one of the other methods, and or our next one, which is lasers.